Hello there guys, Silverly B here, and today I'm going to be showing you guys how to make Atari's Breakout inside of Unity. It's a very simple 2D game where you control a pedal and you have to bounce a little ball around in order to destroy every brick in the level. This tutorial is meant for beginners in Unity, so if you've never made a game before or you've never made a game in this engine, then this tutorial was made for you. First, we have to start at Unity Hub, where you can manage the Unity versions that you have installed and the projects that you have. When you want to create a new Unity project, just select one of the Unity versions that you have installed. Here, you'll be able to name your project and select a folder where you can save it. You can also choose a template. In our case, since we'll be making a 2D game, we can just select the 2D template and let Unity create it for us. Once your project has been created, this is what you see. Unity can be quite overwhelming at first, but don't worry, you can get the hang of the main features pretty quickly. The windows and features that you have will depend on your layout and the version of Unity that you are using. I'm using 2022.1.1F1. It's not necessary that you use the same version that I do. If they are close enough, there won't be much of a difference. What we have up here is the Scene and Game tabs. The Scene tab is where you'll be working on, and the Game tab will show you how the game looks. When you hit play up here, the game scene will run your game. The Project tab has the assets that you have in your project, such as scenes, scripts or sprites, or whatever you want to import or create for your project. The Hierarchy tab has the current scene's name and every object that you have on your scene. The 2D template starts with only a main camera, and if you click on it, you can see its components in the Inspector tab. Here, you'll be able to manage a few properties of the object that you have selected. For instance, we can change the default background color to the color that you want the background to have. In the Game tab, we can visualize what it looks like. We can also, on the Game tab, set the aspect ratio of the game window. I'm setting mine to 16:9. Back in the Hierarchy tab, you can right-click on it to see a few action options. We can select Create Empty to create an empty game object and name it Parent. And if you click on it, you see in the Inspector tab that as an empty game object, the only component it has is a transform, which stores the position, rotation and scale of a game object. If we right-click the parent object and create a new 2D object, sprite, circle on our scene, we can rename this game object as Child, and we can see that it has not only a transform, but also a sprite renderer component on it. In this component, you can change the sprite you're using and the color of the sprite. If you look at the hierarchy, you'll be able to see that the child object is linked to its parent. This child-parent relationship in Unity is very important. The transform of the parent affects the child's transform. So if you move, scale, or rotate the parent, you'll also be doing that to the child object. The child's transform is relative to the parent transform. To see that, we can use a gizmo on the parent object and move it 2 units on the x-axis. If we then move the child -2 on the x-axis, the child will be set at the origin and the parent will be offset to the right. A parent can also have many children, and its children can have children of their own, but any object can only have one parent. Now that we've seen a bit of how the Unity engine works, we can delete these objects and start working on the actual game. We can start by creating a new square object. This one will be naming Paddle, and it will be the little paddle that the player controls. I'll scale its size and position it at the bottom of our camera view. You can see how it looks over at the Game tab. In order to move this little paddle, we'll need a script to get the player input and then change the paddle's position in the x-axis. To make the project more organized, we can create a new folder and name it Scripts. Here's where we'll create all of our scripts. We can open this folder and right-click on it and choose Create New C# script. We'll name it Player Movement. For this script to act on our paddle object, we'll need to add it as a component, just like the transform and sprite renderer components. We can do so by dragging and dropping it on the inspector or by clicking the Add Component button and searching for the player movement script that we just created. To start coding the paddle behavior, we just need to double-click the script and it will open on the script editor. In my case, it's Visual Studio. The basic script template that Unity uses is the mono behavior one that comes with the start and the update function. The comments here explain these functions very well. Start is called before the first frame update, and update is called once per frame. So if we use debug.log to write a message to our console, we can see how this works. We can write start at the start and update on the update function. Once we save this and go back into Unity, if we hit play, we can see that the messages show up. So at the start, there's a single start message, and after that, there are many update messages, since it's being called once per frame. Going back to our player movement script, we can erase these messages and start working on moving the little paddle horizontally. We can create a public variable for the speed so that we can control it on the inspector, and we can also create another float that is going to be our movement horizontal. The horizontal movement of our paddle is going to come from the player pressing the left and right arrows, or A and D. Luckily for us, Unity has a function that gets exactly that. So our movement horizontal is going to be equal to input.getAxis horizontal. This is going to be returning a float between -1 and 1. It's going to be positive when the player moves right and negative when the player moves left. To turn this player input into our paddle's actual movement, we'll access the paddle's transform with transform.position plus equal, and we're going to be adding to it a movement to the right using vector3.right, which is just a vector with a 1 in the x direction and a 0 in the other directions. We're going to be multiplying this by the movement horizontal and also by the speed. Because the update function is called once per frame and there's a frame rate difference between different computers, we need to also multiply this by time.delta_time. That gives us the interval in seconds from the last frame to the current one. This way, the paddle will be moving at the same speed in different computers. We can then save this and head back into Unity to see if it's working. Once we hit play, we can move the paddle from side to side, so it is working. The problem here is that the paddle does not stop at the edge of the camera, and it can just keep going even if it's out of frame. To prevent this, we can set a maximum amount that we can move on the x-axis. Going back to the player movement script, I'll create a new variable and call it maxx, and inside the update function, I'll check to see if the paddle is moving right by checking if the movement horizontal is positive, and if it is, in order to move, the current position of the paddle will have to be less than the max position. So transform.position.x is less than maxx. The other movement possibility is if we're going left and the current position of the paddle is greater than minus maxx. This is if movement horizontal is less than 0 and the transform.position.x is greater than minus maxx. If that is the case, then we can move the paddle. Saving this, we can go back to Unity and set maxx to be about 8 or any number that fits your game better, and hitting play, we can see if it's working. We can test trying to move outside of the boundaries, but if everything is working properly, you shouldn't be able to. Now that the paddle is working, we can start working on the bouncy ball. We can start by creating a new 2D object that is going to be a circle. Then we can rename it to bouncy ball. We can then attach a rigid body 2D component to it, and once we hit play, you'll see that it falls through the screen. Currently, our paddle doesn't stop the ball. That is because neither the ball nor the paddle have a collider 2D. We can then stop this and add a circle collider 2D to the ball, and to our paddle, we can add a polygon collider. Once we hit play, the ball won't fall through the paddle. Now, the ball doesn't fall through, but it also doesn't bounce. To add this bounciness to the ball, we can go to our assets folder and create a new folder for our physics material, and then we can create a new 2D physics material. We can just name it Bouncy and add to it a bounciness of 1.2. We just drag and drop it in the physics material slot in the bouncy ball rigid body, and once we hit play, the ball will be bouncing on the paddle. The problem now is that it just bounces up and down and it doesn't change direction. To fix this, you could use code and even code your own physics behavior, but to make it simpler, what I'm going to be doing is changing the polygon collider on the pedal to have this shape right here. This way, when the ball bounces on it, it will also gain horizontal velocity. We can create this shape in the polygon collider by setting the correct points. Here's how mine ended up looking. You might have to change a few points if your shape is different from mine. Hitting play, we can see the ball bouncing around and no longer does up and down. The problem now is that it also bounces off screen, and that's not what we want. To prevent this, we can create a new object that we are going to call walls and add to it an edge collider and add the points around the screen where we don't want the ball to pass through. Because it's a rectangle, we can use just 4 points and leave the bottom side open so that the ball can still fall through it. Here's how that looks in-game. Now it's time to reset the ball's position every time that it falls through the screen. Let's start by creating a bouncy ball script and adding it to the bouncy ball object, and then opening the script. We'll need to know the minimum position of y for the ball, so we'll create a new public float called min y and set it to -5.5 f. You can adjust the value later in the inspector if it doesn't work for you. Then, in the update function, we'll just need to check if the current transform.position.y of the ball is below the min y. If it is, then we reset the transform.position to vector3.0, so it starts again from the center of the screen. We can save this and test to see if it's working. When we run the game, we can see that it's resetting the position, but it is still maintaining the previous velocity. This is controlled by the rigid body, so inside of our script, we can create a private rigid body 2D, we'll call it RB, and at the start, we can use getComponent and get the rigid body 2D in our object. Then, every time we reset the position to 0, we can also reset the RB.velocity to 0 as well. Another thing you can notice is that sometimes the velocity can get extremely high and it becomes virtually unplayable. To prevent this, we can create a new public float, call it max velocity. I'll set it to 15f, and then we can clamp the rigid body velocity to it. We can do so in the update function and check if the rb.velocity.magnitude is greater than the max velocity. If it is, then we need to set rb.velocity equal to vector3.clampMagnitude of rb velocity to max velocity. We can save this and go back to Unity to see if it works. As we can see, it's working properly, and when the ball falls down, it starts at the center and slowly picks up speed, and it doesn't cross the maximum threshold. Now that the ball is working, we can start working on the brick. We can create a new square on the scene, name it brick, and change its size using the scale. Once it's a size that you like, you can give it any color you want, and we'll also add a box collider 2D to it. In order to destroy the brick with the ball, we'll need to check for any collisions that the ball has. Luckily for us, Unity has onCollisionEnter2D, which is a function that does just that. We can use a debug.log and check in the game that every time that the ball collides with another object, this function is called. So this function is called every time that the ball hits another object. What we need to do then is check to see if what we've collided with is a brick. One way to do that is to create a new tag that we're going to call brick and add this tag to the brick object. Now, every time we collide with an object, we check to see if it's tagged as brick. So if collision.gameObject.compareTag brick, we can just call destroy and pass the collision.gameObject. We can hit play and check to see if it's working. As we can see, it is, and every time the ball collides with a brick, it's destroying it. Now that this brick is working, we can start building a level. You can select the brick in the hierarchy and hit Ctrl D to duplicate it. The problem is, if we want to maybe change the size of the brick or the color, we'll have to go one by one and update it. Since all bricks are meant to be the same thing, we can create a prefab that's going to be sort of a original object that all copies are linked to. We can do this by creating a new folder that we're going to name prefab and dragging and dropping the brick object into it. Now, if we create copies of it in the scene and we edit the original prefab, we can see that all copies have the new changes. The problem now is that it's quite tedious to duplicate and position the objects in the scene, especially if you want them evenly spaced. To fix this, we can create a new script in our scripts folder that we'll call level generator, and we'll be creating the level using it. First, we'll need a public vector2 int that is going to be the size of our level. We'll also need a public vector2 that's going to be the offset between the bricks, and then we'll need a public game object that is going to be the brick prefab. Then, in the awake function, a Unity function that is called when the script instance is being loaded, so even before the start function, we're going to go through a loop the size of size.x, and inside it, we'll go through a loop the size of size.y. Here, we can generate a new game object that we'll call new brick by using instantiate brick prefab and using the current transform as the parent. This means we'll be creating a new copy of the brick prefab in the scene, and it will be a child of the level generator object. The position of this new brick can be set using newbrick.transform.position equals transform.position plus new vector3 I times offset.x and j times offset.y. The z-axis will be 0. This will not be centered. If you want to center it, we'll replace I with float size.x minus 1 multiplied by 0.5f minus I. Then we can go back to Unity, create a level generator object, add the level generator component to it, and set the size that we want our generator to have, the offset, and also the brick prefab. Then when we hit play, the level will be generated for us. Because we have a generator, we can also do some fun stuff when generating the level. For instance, we can create a public gradient, call it gradient, and when we're generating the level, we set the brick color according to the gradient, using newbrick.getComponent sprite render to get the sprite renderer of this brick, and then .color is going to be equal to gradient.evaluate the float j divided by size.y minus 1. This will paint the bricks with a nice vertical gradient. We just need to set the colors that we want in the inspector, and when we hit play, the level will be generated for us. Now that we have the core mechanics working, let's add a score and lives to our game. We can go to our Bouncy ball script, and inside of it, we'll create an int for the score and an int for the lives. The score will start at 0 and the lives will start at 5. Then, whenever we go below the minimum position, we'll remove 1 from the lives, and whenever we destroy a brick, we'll add 10 to the score. Inside of Unity, we can set the inspector to debug. This way, we can check the score and lives, and then we can play the game and see if it's working. Now, every time we hit a brick, the score goes up, and when we let the ball fall, the lives go down. Since it's working properly, we can go ahead and start displaying this to the player. We can start by creating a canvas and setting it to scale with screen size and use 1920 by 1080p as the reference resolution. We can then add a new UI, text Mesh Pro. Once it's installed, we can name this text as score. I'll just write 0000 on it and change the font size. Once it looks okay, I'll anchor it and position it in the corner by clicking here, holding Alt-Shift and selecting the upper right corner. I'll also set the text to be aligned left. Then we can start working on the lives and create a game object that we'll call lives. We can add a grid layout group to it. This component allows us to position its children in a grid. Then let's create an image as the child of this object. We'll name it live. We'll set the image as a knob and the color to be the same color as the bouncy ball. Once that's done, we can duplicate the image 5 times. It's okay if it looks a bit chaotic. The position and size will be adjusted in the grid component. We can set it to have a fixed row count of 1 and also set the cell size to a size that looks okay. I'm setting mine to be 40 by 40 and also setting a spacing on the x-axis of 5. So now that we have the UI, we need to update these through code. Inside the Bouncy Ball script, we can add using tmpro, then ask for a public text mesh pro UGUI, and we'll call this score text. And whenever we update the score, we can also update the score text using scoretext.text equals to score.toString and pass 5 digits to show a 5-digit score. As for the lives, we can ask for a public array of game objects. I'll name this lives image, and then every time we lose a life, we can set that life as inactive using lives image lives.setActive as false. Now the problem with this is that currently the lives can go below 0. To avoid it, we can create a new game over function that only has a game over message, and if lives is less or equal to 0, instead of resetting the game, we call the game over function. We can save this, and inside of Unity, we'll need to set the images and also the score text. You can lock this inspector in place by clicking the lock icon and then select all of the lives and drag and drop them into the array. Don't forget to unlock the inspector after. Then we can run the game and see if it's working. The score is being displayed correctly, the lives are disappearing as they should, and once they're all gone, we get the game over message. Since this message is only being shown in the inspector, we need to create a way to show it to the player. Inside our canvas, we can create a new panel, call it Game Over Panel. Add a text to it that reads Game Over, and duplicate this text to write Play Again. To turn this text into a button, we can just add a button component to it. Now, going back to the Bouncy Ball script, we ask for a public game object that will be our Game Over panel, and inside of our Game Over function, we can set the Game Over panel as active. We can also set the time.timescale to 0. Because we won't be using the Bouncy Ball anymore, we can also destroy this game object. Another thing we'll need is a function to call when we click the Play Again button. We can go to the level generator script and add using Unity Engine.scene management to allow us to manage the current scene, and then we can create a restart function that will set the time.timescale as 1 and reload the current scene. We can do so using scene manager.loadScene and get the current scene with scene manager.getActiveScene.buildIndex. Now, after saving this, we'll need to set the Game Over panel in the Bouncy Ball and also add the onClick function to the Play Again button. We'll also need to set this panel as inactive before hitting play. Then we can check to see if it works, and whenever we lose all of our lives, the Game Over panel shows up and we can restart the game. Once we have the Game Over panel, all that's left to do is to add the winning panel, which is going to work quite similarly, but it will have a "You win" message. So we can just duplicate the Game Over panel, rename it, and then change the message to "You win." Inside the Bouncy Ball script, we'll add a "You win" panel, and we'll keep track of how many bricks there are left with a new int that we'll call brick count. At the start of the game, we'll get the brick count by using findObject, level generator, transform.childCount. Whenever we destroy a brick, we remove 1 from the brick count and we check to see if the brick count is less or equal to 0. If it is, we've destroyed every brick in the scene and we've won. So we can do the same thing we did when the game's over. but this time we set the U-Win panel as active, and we don't need to destroy the bouncy ball as it will be seen on the screen. Save this, we'll need to set the U-Win panel in the bouncy ball, and we can see the finished result of our game in Unity. So this was it for today, guys. If you liked this video, don't forget to leave a like. If you have any questions, leave them down in the comments. And for more videos such as this one, please consider subscribing. I hope you keep on going on your game dev journey. Thank you so much for watching. Bye!